Hey guys, so today we're going to do model evaluation. We're going to evaluate all the models while training. So we're going to separate the dataset into train, validation, and test set. Why are we going to do this? Because if we only have one dataset, that is what we were doing in linear regression and logistic regression. I will put the videos here above. These have some problem. That problems were easy in the first place, and in that example, linear regression and regression. But at this point, if we have more data and more complex problems, we're going to need to separate, because if not, we are going to have a problem that is overfitting, that the model is going to train too hard in the dataset and not going to be able to generalize other data that we give it to it. So first of all, we're going to have some data. Here we have the data. We're going to have the data is about water. We have in the X the training data, the historic data of the water levels, and in the Y, so what we're going to try to predict is the quantity of water that is going through a dam. So we can check the data. Here we have the change in the water levels, this first column, and the second column is the thing we are going to try to predict. So we're going to start here. We're going to put model evaluation. All right, and we're going to start. We're going to get all the data sets. How we're going to do this? We're going to use we're going to, first of all, we need to import all the things we are going to use, and we're going to import it over here. So we need NumPy, we need matplotlib, we don't need this, sorry. We need the minimize and the inline. So we're going to import all the data we need. We're going to need NumPy, we're going to need matplotlib, and we are going to need the matplotlib inline that we put always, so we get the imports here. All right, imported. All right, everything all right. So next thing, we're going to get all the data. We're going to use the load.txt from NumPy. So load.txt. Water data .txt, and the delimiter is comma. I don't know if you know how to use it, but well, if it's going to start here, this is the delimiter, and so okay, this is going to be trained. This is going to be the validation data. We're going to separate it. Water. Okay, water data. Here we have a problem. Train water data. We're going to copy this. Water data. Val.txt, delimiter. All right, and we're having a problem here. Finally, test. Water data test.txt. All right. Is it all right? Water data train var. All right. All right. So let's see. We have some problems. All right. Mistake. Perfect. So we have all the data. Now what we're going to do, like this is all the trained data, but we have to separate here, for example, we have all the data, but we are going to use the X, the first column, and the Y, the second column. We have everything there, so we're going to separate everything. How are we going to do that? X train equals train everything minus 1. So it's going to get all these examples, but till the last one, not including the last one, that is the Y. In this case, it will all be like this. But we're going to put it like this for a future reference because it will be useful for future projects. So here we have the train, and we are going to use this reshape to have it like a column. So now we have this, we can do this. This is X val, test, 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 val. All right. So now we have all this. We are going to separate everything, and let's see. We have the X train and Y train. All right. Awesome. All right. Now we're going to make some visualization for checking what type of data we have. We're going to use some skater, X train, we're going to use a marker X. We're going to put a next label, water level change, and the white label that it will be water in there. All right. Let's see. Right, we have this data. We see we have a clear line that could go like this from to all the points. Okay. Now we're going to plot everything with the validation, the test, and train. We're going to use this example exact same thing. Going to use this. Well, as we need a label here, we're going to put it here, for example. We need a label to later in the legend to know that this is the train. Okay. See, let's see. Validation. We are going to use color blue, for example, here. We're going to use green here, and we're going to have here test. Going to put it over here, and like this. Okay, so we have all this. We need to also set the legend, and let's see what do we have. Okay, so we see the red ones are the training, the blue ones are validation set, and the other the test. So we are only going to train with the train set to later validate with the other ones. All right. So now what we're going to do, we're going to use linear regression as we did, but with these models. What we need to do, first of all, we're going to import linear regression from Sklearn. Okay, so we are going to use the we're going to create the linear regression model. Regression, okay. So now we're going to see how the error is going to change in the training set and in the other set. For example, if we train a lot with the training set, it's going to do really well if we put some data through the model of the training set. But if we put one of the tests, it's not going to be really good. So we need to train it a bit with the train set, but it needs to generalize with the test set. So first of all, we need the model, and we are going to create two arrays of the error in train and train. So we're going to get the number of examples of each set like this. All right, we're going to get the length of train, the length of val, and the length of test. We're going to get we're going to use an array of the length of m train and another one of the length of validation. We're going to use these two. Okay, and now we're going to use a for to, and we're going to train with the training set, and we're going to predict with the training set and with the validation set and see how it's going to do. Okay, for the range, we're going to do it n times. What we're going to do, we're going to fit our baby, and we're going to fit it from time to time. We're going firstly only to train it with the first data, then we're going to try with 2, with 3, till we get like I think 25 or something like that. Okay, so we're going to train it with this and with this. And as I said, we're going to need this. So it's going to train first only the first example. As I said before, we need this. We need this. Okay. Later on, the prediction for train. The prediction we need the model dot predict. As we did before, is train what we have done. All right. Now we're going to predict for validation. Like in the first place, it's not going to do really well because it doesn't know anything. It just has learned one example. Next validation. Here we're going to predict for validation to see how it's doing. And what we're going to put the mean of prediction train at y train, but here we need this, right? And we're going to use the squared error. Okay. For it not being too big, we're going to divide both by 2. Okay. Here we have this. We have we're going to separate the things. X. Whoa. Sorry. I didn't. We need this. We need to put it in the error. I did not. Okay. In the validation prediction from val, y validation. We don't need this here. So here are the 2 errors that we're going to have. Now we are going to write real quick all the things we need. We're going to use some examples. Okay, so here we're going to generate some with line space, some points, and we are going to predict them. We have this example, so we're going to do prediction equals the model is going to predict those data. We're going just to put some data from -50 to 40, like from here more or less to here. Okay, so when this is done, we are going to do some, well, we need to put all the scatter we did before, and I will just copy it from before. We're going to put it over here better. Okay, we're going to predict, and later on, what do we need to do? Later on, we need to call the plot function from x and prediction. See how we're going to do it in quick. Okay, so later on, what we want to do is to see how it went all the progression. So when we go out of the fall, we need to plot all this. We need to plot the train data with the error, like in each iteration, how it went with the error in both sets. So we're going to put some labels. The X label is going to be all the iterations we've done, and the Y is going to be the like this. Okay, and we're going to put the legend. Okay, so let's see what happens. I hope we don't have errors. We're going to put this. Okay, we are deleting this, and we have an error here. Let's see. Whoa. Have the same shapes. Okay, so sorry, the error was that we are trying to use here. We are using we are using mtrain to do all this, and we set this one to m validation, and it's a different set. So like what we are doing is training with the x train. We need to give both mtrain. Okay, so let's see how it does. Okay. What we need to do that we missed, like all this happens because in the fall we are not creating a figure, so it's everything in the same figure, and we need to put over here. We need to write this to create the figure. So okay, let's see. We're going to click here. So here it has only learned this example, this cross here, this red cross, and the training set. So the line that it has learned is this one. Later on, we've learned two examples, so we know this thing. Now we know these 3 points, so it's creating the line. Let's see, here we have an horizontal one, and we see that later on we have created and more or less here it's been good. So here's the last one, and this is the final line that has learned. So this doesn't have much sense. Let's see what we have wrong there. Maybe the error that we are here, and it should be around here. Yeah, this it should be like this, and but here we need another parenthesis. Here and here, and we're going to need this. this. Okay, let's see how it does. Well, what we've learned, alright. And finally, okay, this does half cent. Okay, so in the training set, we didn't have much error, we increased a bit the error, and in the validation set later on, we had this error. Like in the training set, we are not having error here because there's only one example. So later 2 examples, here 4 examples, here 6 examples. So it's not that accurate. In the validation, we see we have a lot of error here, but when we've learned almost 4 examples, 3 examples, it has really learned a lot. 2 examples, it's really decreasing. And over here, it's much more of the same. And finally, what we're going to do now is to use something that is called polynomial features. What is this going to do? As we saw over here, this is a straight line, and it would be better. Here we will see it much better if we go up here. Like it would be better if it would have some curve. Like over here, if it would start here in minus 50, minus 45, and it will go down here, and then it will go up in the top right. So we are going to import the polynomial features, and we're going to create an object as we see, and what we're going to do is to use also the standard scalar. We are going to use the feed transform to transform our X training data, and with the scalar we're also going to transform the X train, the new data that we are going to transform with the polynomial features. So let's see how this is going to work. As we see with the polynomial features, here we have some example. Here we have a straight line, that is what we have now, and we would need some curve. So here we get with the polynomial features, here we only have an x and another value, and here we have some squares that are curves so we have much more options with the polynomial ones. Okay, so let's see how it's going to do. All right. Now we are going to have some variable we're going to use 6. And it's going to be the input that we're going to put into the polynomial features. So we're going to create the object with polynomial features, polynomial features of the m, and we're going to put this y equal to false. Because this means that we are not going to include the ones that we did in linear regression. We don't have the ones in the X string, so we would include it itself. Later on, we create the scalar one, scalar. Alright, so now we're going to transform our data. Extreme poly is going to be poly dot fit transform, as we said before, of X train. Alright, and now for X train poly, we're going to transform it again. That's going to be poly, and this is going to be scalar dot fit transform, X train poly. Okay, so we have both transformed. What do we have to do now? We have to transform also the validation on the test set. Validation, validation, scalar, validation, fit transform. Okay, we have everything here. We copy this, we paste it here and here. Okay, so now we have all the data. Let's see. We have some error here. All right. Scale. Okay, so we have all the new data transform. Let's see what we're going to do now. We're going to plot it everything to see the new curve. There's not going to be like this. It's going to have a curve for the grade we're using. Like this is the grade we're using. In those examples, we only had a grade of 2. Here we have 6. All right. So here we're going to create our linear regression model. Again, we're going to feed it with with our new poly data. We have so now we're going to create a figure and we are going to make a scale. Yes, okay. Before we have train, we have validation. Okay, train. Yeah, like in the scalar, we do have to use this. We are not using the train poly because it's like another thing. But to plot it and to see it, we need to use the one we had before. And well, sorry, here we need to use this thing. Okay, we need this and we need this. Okay, sorry about that. I copied from another thing that I had in Spanish. Okay. Okay. So now we need to plot this here and to use the what are we going to do? We're going to create a line space again. Space from -50 to 48, for example. And we're going to use 200. And we are going to make it like before a color. Now what we're going to do is to make poly of these two. So we are going to make a fit transform of this data we are making like this, and xx poly equals poly scalar dot fit transform from xx poly. Okay. So later on, what we're going to do is to predict this. We are going to use our model to predict xx poly. We're not going to use any limiter and we are just going to plot it now. xx with the prediction. As before, we are using xx and not xx poly. And like this. Okay. Okay. Finally, we're going to get all the error to print it and to see how well it did. So now we are going to see the error of validation and train to see how well it did. We're using 0.5 instead of dividing by 2, and everything is all right. We're going to print it here. Print train here in validation. Okay, so let's see. We have an error. Linear regression. Okay. The white train is not defined. Okay, yeah, sorry. White train line 2. Sorry. Okay. Okay. But let's see. We have an error here of 0.19 and here from 18 of error. Here we can see that we now have a curve and it's going to predict a bit better with this line, because the other one was too straight and it's not going to, and it was not really worth it. So well, I hope you have liked the video, and if you have any questions, just write it down below. And we will do next some nice bias and neural networks in the following videos. Thank you very much.